Good morning, everybody. Welcome to another edition of Grade School. Really excited to be back with you guys. We've got a special grade school today. We're going to be focused all on ACES and really try to explore the nooks and crannies of ACES that we haven't had the chance to cover before. I missed you guys because we took last week off, so I'm really excited to be back with you guys. I've got Raphael here co-hosting with me. He's going to help me get y'all's questions answered and keep our chat organized. So glad to have Raphael with us. And I'm going to start by talking about just a couple things before we get to questions. So first of all, if you haven't heard about this Learn with the Masters event that's taking place later this month, June 26th, you definitely want to go check that out. I'm going to be on a panel of about a dozen of the absolute best colorists in the world, and it's going to be an awesome event. It's about 8 hours of total instruction, and it's well worth the registration fee, and all of the proceeds from the event are going to be going to COVID relief efforts in India. So definitely a worthy cause for your money to be going as well. But definitely want to encourage you guys to go and check that out. For my part, we're going to be talking about image science and specifically how we can use it as artists, because it's something that you guys hear me talk a lot about image science in sort of a tangential way here on the channel. But kind of my thumbprint and the way I think about image science is I am an image scientist and I fool around with image science to the extent that it helps me to get better results as an artist. So that's kind of going to be the theme of that conversation, is how we can use image science not for the sake of complicating our workflows or being the smartest guy or gal in the room, but how we can use it to actually get better images. So I'm really excited to share the stuff that I've put together for you guys for that talk, and I guarantee you every other speaker at that event is going to be well worth listening to. So definitely go check it out. There's a promo code if you want to get 10% off. You can use Cullen10, that's C-U-L-L-E-N, the numeral 10, 10, to get 10% off the registration fee. So head over there and get signed up as soon as you can. And with that out of the way, let's start by talking about ACES, and in particular, one of the sort of misunderstood and mysterious aspects of ACES, and that's the RRT. That stands for Reference Rendering Transform. And you guys have heard me talk about the RRT before, but I want to go a little bit deeper into it because we've got some questions we're going to be covering today about the nature of the RRT. And I want to give everybody a bit of a better understanding of what this is, where it comes from, and how it relates to other color management solutions such as Resolve Color Management. So the RRT, the Reference Rendering Transform, was the solution that was devised right at the outset of ACES for, in addition to sort of creating a neutral, technically accurate transformation from what the camera saw into our working color space and then finally out to our display color space, the RRT is going to impose a little bit of a look, a little bit of contrast, a little bit of preferential color mapping. In short, a lot of the stuff that we like in a film print, a lot of the jobs that a film print would traditionally do. And here's a really fascinating thing that I was kind of floored by when I discovered it one day. The original RRT, and it's important to note, we're going to talk about how the RRT has actually been not only conceived, but how it has evolved over the years. It has changed. It has not been one fixed transform over the different versions of ACES. It has evolved. But the very first RRT, the RRT that came along with version 0.1.1 of ACES, was actually developed in partnership with Fujifilm. And what the Academy did when they went to Fujifilm is they said, we want to produce a reference rendering transform with a film-like response. And I'm just going to read you guys a couple passages from a research and development document that is floating around out there in the dark corners of the internet if you care to poke around and look for it yourself. But I want to read just a couple highlight passages. The first one is in the very opening paragraph of this R&D doc, where they say that the workflow, meaning ACES, targets the facilitation of digital cinema production comprising a wide range of procedures. Fujifilm contributed in the solution of one of the major technical issues, reference rendering transform. This transform needs to have film look reproduction, huge dynamic range coverage, and very precise accuracy for its inversion. So this document goes into a lot more detail from there, but their kind of core argument or thesis is we were asked to make a reference rendering transform, basically a device agnostic look, a look that's dependent neither on the input device or the output device, which has a film-like response or a film-like reproduction. And this kind of blew my mind the first time I heard it, because I had sort of like observed it in the RRT, but I didn't quite know what I was looking at. And I found it so fascinating that indeed, when we first began to work with color management in an organized and standardized way with ACES, our starting off point, our jumping off point, was to emulate the response of a film print. It makes perfect sense when we think about it, but I just think it's fascinating that this was sort of our initial starting point when we were getting into color management in a more organized way in 2010. So that's kind of the first thing to observe. And the other thing that that tells us now is, if we go to a question that we've talked about a lot here on the channel and in grade school of, okay, Colin, now that I'm working in a color managed or a scene referred environment, what's the best way to go about, or what are the different ways to go about getting a really high quality film emulation, a print film emulation? Because it can be, or feel anyway, a little bit trickier than if we're working in some other format. If we're working in like a display referred or a more traditional, like I've got a log image and I just need to transform it to Rec 709, that's where we might be able to use something like our built-in Resolve Film LUTs to get from Cine on log out to Rec 709 with a film look in between for a 2383 or a 3510 or whatever. But one of these big questions that comes up, rightly so, it's a question that came up for me when I started working in color management, was how can I go about creating a high quality film print like response in this sort of advanced color managed ecosystem? So what's interesting is, even though the ACES RRT has evolved and has actually moved further and further away from this sort of like filmic response, because one of the things that the committee in charge of the ACES initiative discovered early on was colorists and other filmmakers saying, hey, we actually don't want you to impose that strong of a look on our behalf. We would rather have a more neutral transformation where we can introduce our own look, whether it's something filmic or something else that we have control over, as opposed to having to use your RRT, which, as you guys may know, there's really no way to sidestep in ACES. If it's in there, we have to use it. So let me flip over to my Resolve real quick and just give you a quick demo of what I'm talking about. So I've got this ACES, what they call it, one of their golden images set up here. It's just a test image that you guys have probably seen me use before. And I'm going to drop an ACES pipeline onto here. So we've now got a normalized image, and we're doing our normal thing of going from our input camera color space, Alexa, into our ACES CCT working space, and then out from our ACES CCT working space into Rec 709. So all normal vanilla stuff you guys have seen me do before. Of course, I could set this up in the exact same way in my project settings, but as you guys know who've been hanging out with me for a while, I prefer to do things in nodes for a variety of reasons, but one of the key ones is that I simply like to see my entire imaging pipeline spelled out in nodes, as opposed to having to kind of envision and imagine it as it's happening under the hood without having a tangible kind of visual reference point for it. But with this sort of basic color management, ACES color management sandwich setup, I want to show you guys a little trick or a secret that's hiding in your LUTs folder. I'm going to go to my LUTs here, and I'm going to go to ACES, and I'm going to look at my LMT ACES version 0.1.1. This is actually I can't remember if it's a cube or I believe it actually is a cube. But at any rate, it's a look file that is shipped by default with Resolve. And if I double click on it, I'm now getting closer to the response of that ACES 0.1.1 RRT. So that original RRT that Fujifilm helped develop, that was going to give a reasonable characterization or a reasonable film-like response, is actually available to us here in Resolve. So this is one of the best ways, and kind of a lesser known way, of getting a film-like image right off the bat with tools that are freely available right here inside of Resolve. So we're going to see a lot of the common characteristics that we see with many film emulations here, but I wanted to just kind of point that out to you guys and encourage you to play around with it, and also sort of give you this overall talk about the ACES RRT, where it began and where it has evolved, as a way of kind of better understanding ACES. Because for my money, the RRT is one of the very key sort of distinguishing factors of ACES compared to something like Resolve Color Management or the ARRI color management system that they've created that you can also get access to. The main factor there is really the RRT, because even though it's moved away from a strictly film print-like response, it still has quite a bit of character to it, and it has its own look above and beyond a more technically neutral transformation. So that's kind of one of the key unique aspects of the ACES color management workflow. It's neither good nor bad, but it is the result of ACES being one of the first color management solutions on the scene. And it has evolved from a point of like, well, hey, we should be giving our colorists and our post facilities a image pipeline that is really similar to what they're used to, which at the time was doing digital intermediates, grading underneath a film print LUT that was really just meant to give an accurate preview of what the film was going to look like when it actually was printed back out. So they were kind of trying to meet artists and facilities where they were, and the ACES 0.1.1 RRT is what they came up with. It has since evolved and moved in a different direction, but we have the ability to invoke that version of it if we so desire. So just kind of some interesting backstory to the ACES system that I wasn't aware of for quite a long time after I began working in ACES. So with that said, let's go to questions and see what we've got. What else we want to know about ACES today?
Right, we have this question from Sek Mackenzie. I know you browse over this one in one of your videos, but I always notice you have a 100 nit luminance mapping node before your output. Not sure if that's because you're working in every log C or not, but my question is there any luminance mapping I need to do working in a CCT space before my output? I know 709 has a output of D65 and ACES D60, but I'm unsure if the ACES output transform handles that or not.
Yeah, this was a great question from Zeke that I'm glad to be getting to touch on today, because this is going to piggyback on what I was just talking about, of kind of like the key unique factors in these various color management solutions. One of the other key factors in ACES, aside from the RRT, which we just talked about, is the way it handles tone mapping and the way it handles gamut compression, actually, which we're going to talk about in a moment. So let's wipe out this color management system that I've built here, and let's just go and build, I'm going to set up the output transform that Zeke is referring to having seen me use in the past, which is this right here. So I'm going to clean up my node graph. And he's talking about seeing, in addition to my 709 output transform node, he keeps it spotting this 100 nit scaling node here. Now, there's a couple things there's a few things to discuss here. The first is that just in broad strokes, even setting aside my particular node graph here, unlike in ACES, where all of our tone mapping, all of our white point conversion, as Zeke alludes to, and all of our transformations are sort of reduced down into, okay, what's the input color space and what's the output color space? And that's really the only parameters that we can provide to the ACES system. Unlike that system, the Resolve Color Management has a few more options available. Now, that's neither good nor bad. It depends on what our needs are and what our level of sophistication is. As you guys have heard me say before, I like to start with ACES because it has such a simple modular set of user parameters where you're basically just providing the bare bones information. What's your input color space? What's your working color space? What's your output color space? And there's very little option. There's really no option beyond setting those parameters as needed to the correct color spaces. Resolve Color Management, by contrast, has quite a bit of luminance mapping and gamut mapping options that it makes available to us. So let's actually break my rule for a minute. I'm going to set aside my node graph here. I'll come back to it in a moment. And for now, I'm going to disable all this, and I'm going to go to my project settings, and I'm going to look at what I'm given as options when I set my color science to DaVinci YRGB Color Managed, which is how I invoke Resolve Color Management V2 at the project level in Resolve 17. And I've got these presets here, which we can talk about at another time. But for now, I actually want to go to custom so that we can specifically see all of the parameters that we do have the ability to control in Resolve Color Management V2. So let's just take a look at how many menu items we have here. We have input color space, timeline color space, output color space. Those are going to correlate with those same three color spaces that I just enumerated that ACES wants from us. But then we have all these other options. We have a timeline working luminance. We have the option to limit our output gamut. We have our input device rendering transform and our output device rendering transform. This is shorthand for the way we want Resolve to handle our tone mapping. So unlike ACES, where the way we tone map from, say, a Rec. 709 piece of source or an Arealog C piece of source into our working color space, that's handled automatically. It is a fixed variable that we have no ability to modulate in the default ACES system. Here in Resolve Color Management V2, we actually have quite a bit of control. So with these DRTs set to DaVinci, that's basically just a static scheme that is going to be invoked on our behalf that we don't really modify any additional parameters within. But just as an example, if I change myself to luminance mapping, which is the tone mapping scheme that I'm using over here in my node-based color management that we're going to go back to in a moment, we're going to get all of these additional options available to us. So if I say, let's set my timeline working luminance to custom, and let's max it out at 10,000 nits, which is kind of the ceiling of the container. And what's going to happen now is this output DRT is going to create a custom tone mapping that's going to take me from 10,000 nits to the 100 nits that we know our output color space is sort of capped off at. So it's going to change the behavior of our final output transform from working color space into display color space is actually variable depending on how we set our parameters here. In ACES, as we said, no such variability. It's going to be the same fixed transformation. If I'm going from ACES CCT to Rec 709, that transformation is always going to be identical regardless of anything I do because there are no variables for me to modify. Here in Resolve Color Management, I can actually change the behavior of that tone mapping by changing my peak luminance here in my timeline working luminance. And to add another sort of layer to the onion, if you're not completely overwhelmed yet, that same logic actually goes for when I select anything but custom here. I can select all of these different working luminances. Let's say I set a working luminance. This would be a bad idea, but just as an example, if I set a working luminance of SDR 100 and I have an input color space of Verilog C, Resolve is actually on my behalf now going to use its dynamic luminance mapping algorithm to take me from the theoretical 10,000 nit ceiling of an Verilog C tone curve and map it down dynamically into the nit value that I have specified here. So that's a big jump, and we would see it represented in our timeline if we did that. So we can alter not only the output tone mapping rather, but the input tone mapping as well in Resolve Color Management V2. Pretty cool. It's like driving a stick shift. If you really want all that control, you want to get somewhere faster or have more control over your experience, it's a really good set of options. As you guys can probably also see, for anyone who's not hip to color management and well-versed in these ideas, this is a little overwhelming. It's a lot of variables, and at the end of the day, they may or may not make an enormous difference to the quality of your final image. So it's best to kind of move in stages with this stuff. You want to crawl before you walk. Start with ACES. Start with having most of those parameters sort of set up for you. Maybe then you could move into Resolve Color Management and look at using one of the presets that are here that are going to fill in kind of all of those variables we were just looking at on your behalf, so you don't have to articulate them all yourselves. But that's kind of like the spectrum of like sort of preset values versus full control that we can explore depending on whether we're using ACES or another system. So since we're talking about ACES today, again, all that stuff is fixed. In Resolve Color Management, we have more options available. And just to circle all the way back around and actually answer the original question, what's going on in my timeline output node is for reasons that are now, I think, unnecessary. I haven't fully tested this out, but for reasons that are now unnecessary, I was actually doing my luminance mapping upstream of my final output transform, where I was doing my Alexa log C to Rec 709 gamut 2.4 and my gamut compression to kind of squeeze and fit that big wide color gamut, a very wide color gamut into the Rec 709 primaries. I was doing my tone mapping rather than here. I was doing it up here in a separate node in Resolve 16 because I just found that I was getting a better preservation of my middle exposures, which is kind of my baseline priority for an output transform. Is if something is metering at 18% gray or 13% gray in my working color space, it should also meter there after my output transform. And I was finding a more tight alignment between those measurements by doing things this way. I don't think that's necessary anymore, and it's kind of an idiosyncrasy of mine anyway. But that's kind of why these are explicitly set up as two nodes. I could now, if I wanted to, get the same effect by doing my tone mapping here, using a custom max of 10,000, a custom output of 100, and then modulating my adaptation to match. But to go back to the very original question, this is something unique to Resolve Color Management. It's not something that you need to control or even that you can control inside of ACES. Inside of ACES, it's all set up for you.
This question from Caleb Cargas. Sometimes the ACES 709 RRT ODT can come off a bit too contrasty in certain scenes. What's the best way to tone that back? Also, since ACES CC, ACES CCT are log, does it make more sense to not use the S-curve feature?
This is a couple of really good questions that are unique to ACES. So we've got a couple things that we're talking about. The first thing is let's go back to our ACES pipeline and observe that, you know, if I grab a still of just my stock pipeline right here in ACES, reset all my grades and nodes, and then reapply my sort of stock Resolve Color Management output transform that I'm using for the most part these days as my starting point. So in both of these cases, all I've done is set up technically accurate color management. You guys have heard me talk before about how because we're mapping from a big color space, wide dynamic range, into a smaller color space with smaller dynamic range, even within that technically accurate set of transformations, there's some subjectivity and some judgment calls to be made because, to belabor my favorite expression, there's no way to fit 10 pounds of dirt into a 5-pound sack. We can only be smart about which 10 pounds we fit into the sack. So we've got two theoretically neutral color space or color management solutions in place here. But if I wipe from my Resolve Color Management version of things to the ACES one, I'm getting a different result, right? And you can see visually as well as down here in my histogram, as the question correctly identifies, there's a thicker, a fatter contrast curve going on here in my ACES version of color management than here in my Resolve Color Management version. And this is, again, part of ultimately the factors that should be going into your thought process when you are selecting your color management solution. But we should also be able, within whatever color management solution we have, to move things in the direction of our creative agenda. So let's go back to our ACES version and talk about the question of what to do about the contrast level of the stock ACES RRT when it feels too heavy as a starting point. What I would say is that would simply become part of the sort of raw ingredients of my look, of my global image transformation that's going to be about aesthetics rather than about technical transformation. And that's going to happen probably in a real world implementation. It's probably going to happen on my timeline level or in the group post clip level as opposed to here at the clip level. But let's keep things all here for now and just kind of explore that idea. So there's lots of different ways that we might look at this, but probably the simplest way would simply be to do a neutral contrast reduction. So just because we have that fat S-curve downstream doesn't mean that we can't decon the image upstream and feed it into that RRT and get a resultant lower contrast image. So I could modulate my contrast like so. This would probably be my go-to for backing off my sort of stock baseline level of contrast if I'm working in ACES and I feel like just the baseline color management is feeling a little bit too heavy in terms of that overall contrast. And this leads us right into the second part of the question, which was also really good, of, hey, since we're working in a log space, do we need to use the S-curve feature? And I will have to confirm that I'm interpreting the question correctly, but I believe what the question is regarding is if I go to my project settings and I go to my general options, you guys have probably seen me mention this once or twice before. I have this option here to use S-curve for contrast. And let's just very quickly actually get a look at what that's doing under the hood. So I'm going to disable all those nodes, and I'm going to pull up my favorite tool, the grayscale ramp, and I'm going to pull up a waveform down here, and let's pop it out so you guys can actually see it. And I just want to show you guys the difference between if let's do this and scale this guy down a little bit so that I can see everything I need to see. So if I go right here and add some contrast, you can see when you look at my waveform, this is what we call linear contrast, which just means that we're pulling the bottom down and stretching the top up in roughly equal measure at technically a 0.435 ratio of shadows to highlights. But if I now go to my project settings and turn that option back on to use S-curve for contrast, and hit save, I'm perceptually getting a similar level of contrast here in the image. Like the increased contrast that I'm seeing in the image didn't change a ton when I flipped that option on, but you can see here in my waveform, I went from that linear form of contrast into a rolling form of contrast, which is the bedrock of good tone mapping. We need rolling shoulder and toe. We need rolling contrast that has a shoulder and toe component. It needs to be deployed at least a few points in our imaging pipeline if we want to get a faithful and pleasing reproduction of our original image on the finite dynamic range of our display. And I don't care whether you're talking about an HDR display or a traditional SDR display. Either way, we are challenged or faced with the same fundamental challenge of scaling down a very, very big dynamic range into a finite dynamic range. It's just a question of how finite. So anytime we need to do that, S-curves are going to be our friend. And in fact, if I go back to the ACES RRT, or our final output transform, an S-curve is exactly what we're going to see there. So if I let's turn my ACES pipeline back on for a moment and just look at this output transform, it's a big fat S-curve, right? And if instead we tried to get reasonable perceptual contrast by doing linear contrast, we would be clipping out tons and tons of shadow and highlight information. So S-curves are our friend. They play a vital role in any imaging pipeline where we're dealing with getting something from what the camera saw into what our display can reproduce, whether that's SDR or HDR. But the question is, going back to the original question, since I'm already in a color managed environment, and since there already is an S-curve and likely two S-curves in my color management pipeline, should my clip level, like creative contrast or corrective contrast potentially, that I'm applying by hand in Resolve using my control panel or my mouse and keyboard, should that contrast be linear or should it be S-curve in nature? Because this option, I believe, as of Resolve 16, and I think it's the same in 17, this box is going to be ticked by default. It's going to be on by default. So the question, which is very well placed, is should this be the type of contrast that I'm introducing in or out of my image, or should I be doing linear contrast since I'm doing all these other S-curves downstream and I may not want to piggyback more and more roll onto the imaging pipeline? So your mileage may vary, and I encourage you to try out both. And in fact, one of the best things you can do, if I turn my whole pipeline back on here and I play with some positive contrast just for a moment, one of the best things I can do is make a kind of extreme contrast adjustment and compare the two different versions of my image. I could even do it like this. Let me go back to kind of my normal scopes that are going to be hiding under my face for now, but we don't need to see them quite as much at the moment. If I save a still of what I've just done here, where I've added like this, quite heavy bit of contrast, maybe we'll back it off just a hair. Let's grab a still of that. And now let's go to our project settings and turn that setting off. You may or may not see any difference at all, depending on the image you're on. In fact, the only place you can really identify the difference right now is in my scopes. When I wipe this on or off, you can see there's a slight change in the mapping of the shadows of the highlights. But that's really the best sort of like aesthetic way to answer the question, is just to try contrast manipulations of different types on different images and get a sense for how that option being turned on or off is going to affect them and which you prefer. But I would say in general, I would put the burden of proof on the S-curve form of contrast when you are in a color managed environment. And I'm going to give everybody in the room just a second to ponder why I would say that. What would be my sort of like baseline reason for wanting, or for saying that would be the way to handle this? It's a concept that I've talked about a lot before. I'll give you just a second while I get a chance to sip my coffee. The reason is linear contrast is simpler. We always want to be looking for the simplest possible solution, and there's no reason to be afraid of complexity, but complexity should be deployed when simplicity doesn't do. So in this case, linear contrast, simpler than S-curve contrast. So if we can get it done with linear contrast, there should be no need to add the complexity of a rolling S-curve and that slightly more tricky math that goes into that operation. So big, long answer to that question, but that would be my answer there in terms of like backing off what you're getting out of the RRT by default just back off your contrast a little bit. And then that's probably going to work even better, specifically when we have the S-curve for contrast option off, because it's going to allow you to actually truly lift your floor and drop your ceiling a little bit, as opposed to just stretching out your knee and your shoulder within a dynamic range that you're not actually reducing. So I hope that helps.
All right. This question comes from Luke Turner Media. On the ACES Transform OVX nodes, what are the ones tagged with CAC?
Yeah, so that's kind of a new thing in the ACES 1.2 implementation. And I don't know if that's new because of something that's actually designated or specified in the ACES release, or if it's a convention that Resolve decided to go with. But let's just talk about kind of that difference, because I'm doing my ACES nodes here in ACES 1.2. And the question is regarding what's up with the CSC thing here, because in ACES 1.1, if I was going to select ACES CCT, oh, interesting. It's actually moved in Resolve 17. Now ACES 1.1 has the same change in the name. So I think it might be a Resolve thing as much as an ACES thing. So I was going to kind of contrast one versus the other. Like, I just wonder if we go back to all the way to ACES 1.03. Yeah, even there, those things are living inside of this CSC category. So I'm going to hypothesize that that has more to do with Resolve than with any naming convention that the ACES committee have stipulated. But long story short, what that stands for is color space conversion, and why they've chosen that naming scheme, I'm not exactly sure. You know, technically, ACES CCT and ACES CG and ACES CC are what we call working color spaces that we shouldn't actually be archiving or finishing our work in. There should be a big unified like ACES linear container for our archived material. So maybe this is just helping designate like, hey, this is a convention a conversion that you should be using in order to facilitate proper like creative workflows, but it's not necessarily a color space that you want to be like archiving things in ultimately like you would with, say, ACES up here at the very top menu. That's a wild guess, but I think it's just a naming convention that seems to have been implemented as of Resolve 17.2. And the fact that it ripples all the way back to ACES 1.03 tells me it has more to do with Resolve, maybe even with Resolve wanting to better align its naming scheme to what they're seeing in the reference implementation for ACES, but it's more to do with something that's changed in Resolve as opposed to something that's changed in ACES. We've just had these couple of sort of transplanted color spaces that were at the very top of our drop-down menu and are now all under this CSC section.
Okay, this one comes from Jamin Devon. And can you make camera shooting LUTs with ACES?
Yeah, you absolutely can. So if we talk about it in the simplest possible sense, if I wanted to provide a completely neutral, look-free Alexa to 709 via ACES color mapping LUT, I could start with what I have right here. Just make sure I've got my pipeline set up properly. And if I right-click on this node and I say Generate LUT, maybe do a 33-point LUT because most cameras are not going to be happy with a 65-point. And I'll give it a decently descriptive name. I'll say, like ARRI to 709 ACES. And after I hit output here, there's going to be a big long suffix that I need to trim off. But if I do that and then just preview it here in Lattice, which I highly recommend for anybody who's doing any work at all with LUTs. And once I hit open here, you can see in Lattice a preview of what this LUT is set up to do. It's basically just a big old curve taking you from your log space to your Rec 709 space with obviously some more complicated color remapping happening here on the cubic side of things. But yeah, absolutely. That would be kind of the baseline, and then you could build from there. And obviously you would want to do any kind of look dev in between your in and your out. And any adjustments that you make inside of here will also be baked into that LUT when you go to export it, provided they are not coming from DCTLs or from a couple of other sort of like forbidden classes of manipulation for LUTs, like more limitation of the LUT system itself. Like you couldn't put noise reduction, for example, or grain, because those are things that can't be encoded into a LUT-based system. But anything generally that can be encoded into a LUT, you can apply as a manipulation, with the exception of a DCTL.
Okay, this one comes from Pedro Erzal. Hey, wanted to ask why use Mac display color profiles for viewers should be turned off when doing node-based color management.
Yeah, that's a good one. I forgot we needed to kind of follow up on that one. To be honest with you, I don't know, except to say that because I don't have a very three-dimensional understanding of the of Mac OS's internal color management system. And that, by the way, is what we're talking about when we talk about the Mac display color profile. It is trying to use a profile that it has created that you can think of. It's an ICC profile, basically, which we can think of as a sort of specialized LUT. It's a set of transformations that's meant to take an input image in a particular state and transform it into an output image. And in this case, it's designed as we can think of it as a correction or a calibration LUT. The goal of those display color profiles, as you guys may know, is to get more faithful reproduction of the desired color space on our monitor. So there's a couple problems with that, and the main one is that they're not based on measured data from our actual unit that we're using, so we have no real reason to trust that that measured data that it was derived from is going to be the same data that we would get by measuring patches on this display. But my hunch as to why that breaks things is because that ICC profile, like a LUT, is a picky eater, and it is expecting a normalized gamma state image, like an sRGB with Rec 709 primaries with a gamma curve type thing. And it's simply seeking to make a transformation of that state of the image into a slightly modified version that theoretically will more faithfully reproduce the target color space that our display is supposed to be hitting. The problem is when we are working in a node-based system, we are feeding it a different state of image. It's a log state image, and I think that's probably why it's breaking. I mean, let's kind of explore this for just a moment. I can't even remember where that thing is. Well, let me see. If this turns on automatically here, guys, then we'll explore it for a moment. If not, then yeah, so I'm gonna have to do a relaunch. So, well, I'm not gonna go all the way down that rabbit hole, but that would be my hunch as to why the Mac display color profile for viewers thing is not working properly. And I would also encourage you guys, if I can sort of rephrase the question or the challenge a little bit, that Mac display color profile is really not your ally. There is really no substitute if you are wanting to grade images that are going to look the same here as there, as on your grandma's television or your buddy's cell phone. The best tool, really the only tool that we have that's going to allow us to do that, is to grade to a standard, to grade to something like Rec 709 and monitor on a display that is faithfully reproducing Rec 709. And the only way to ensure that a display is faithfully reproducing any color standard is to measure its performance with a specialized instrument and come up with a correction LUT that allows you to more tightly align that display with what it should be doing. There's really no substitute for that. So the Mac display color profiles are not built on such a system. And even if we're using, something like a spider checker, which I hear people asking about from time to time, those simply aren't precise enough instruments for our application in image mastering. And I'll leave you guys with this thought on that. If we think about this sort of goal of faithful image reproduction as a dartboard, and we're trying to hit the bullseye every single time, right? If our display is right in the center and our display is perfectly reproducing the characteristics of our destination color space, if we hit the bullseye of a dartboard, I want you guys to just do this thought experiment for me. What is the maximum distance that any other dart that even hits that dartboard, what's the maximum distance that that dart can be from the center of the dartboard, from the bullseye? It can be 1/2 of the total diameter. My geometry is a little rusty. It can be 1/2 of the total distance across that dartboard, right? Because the furthest it can be is at one of those outer edges, and it could be as much as half of the distance of the dartboard away. Now I want you to contrast that with another thought experiment. Let's say that I have a display that is hitting not at the bullseye, but it's hitting, like 25% under and to the left of the bullseye. So sort of halfway toward the outer edge. I've not really hit my my bullseye anymore. Now, what's the maximum sort of distance between where my display hit and where any other display might hit? It's much larger now, right? Because it can be as far as from that point all the way to the upper edge that we just mentioned before, but that's a further distance to travel. So it's kind of a simplified analogy that doesn't scale perfectly because color is actually much more complex. It is three-dimensional rather than two-dimensional, like a dartboard, but the maximum error, the maximum discrepancy between what we should be seeing and what the display is reproducing, the only control we don't have control over the displays people view stuff on. We don't have control over whether their display is calibrated. The only thing we can control is our display, and since that only makes up half the equation, every inch of accuracy that we can gain matters, and every bit of inaccuracy matters as well. So again, the only real solution there is to have a display properly and professionally calibrated so that we know, hey, you know what? The part I have control over, my display, it's dead on. So anybody else, they're only going to be suffering from a maximum excursion of half of the dartboard in this analogy. And there's nothing I can do about that short of sending out a calibration professional to go and calibrate everybody's display who's going to be watching my content. So very long answer, but with a fun tangent built in there too. So I hope that's helpful.
Okay, before the next one, just want to greet Darren Mostin, who's here in the chat, enjoying this session as well.
All right, Darren's
the
here.
Next one, yeah.
Awesome.
Yeah,
and sorry, go ahead.
I'm also a big fan. So let's go to the next question from VM. Does converting Rec 709 footage to ACES, then back to Rec 709 for delivery, affect the quality by converting from lower color space to a wider one, then back again?
Good question. In theory, no, but in practice, it can. So it's something that we want to lab out, and we've talked about this before. In theory, the process of exploding out into that wider dynamic range and compressing it back down, that in and of itself shouldn't be degrading our image any further. However, there is some gamut mapping that's going on the output side in ACES that is altering our image. And then there's, of course, whatever we are doing inside of that larger color space. Both of those things can lead to a degraded image. In my experience, that's only on the extreme end of, like very, very problematic underexposed or low bit rate or low resolution source material. Most of the time, it's a very tenable compromise, and one that I would actually recommend going with, because even if I have to, do I have any Rec 709 stuff in here? I don't, but that's a good thing to keep in mind. I mean, you know what? Let's do kind of a silly experiment for a second here, guys. Let's say that this state of my image on node number 3 is my image, and I don't. This transform out to Rec 709 is already cooked in here. And let's just talk about, basically doing another round of my color management here, but we'll just pretend this didn't happen and that my image came to me in this state without these upstream transformations. So let's say we're going to do an input transform from Rec 709, and we're going to go to ACES CCT, and then we're going to go back out to Rec 709. So within here, I'm going to have, again, just sort of like using our imaginations a little bit, that in this Rec 709 source image that I am working with, I am, to go back to the original question, I am probably not going to, at this stage, go like, oh man, just that round trip of going from Rec 709 into ACES and then back out to 709, I feel like that's harming my image in some way. It is changing it slightly, and we've actually talked about this in prior episodes of Grade School and other videos. If I look at my vector scope, if nothing else, the tone mapping up, tone mapping down, and gamut mapping are slightly changing my colors just a little bit. So it is changing, but it's not actually degrading anything quite yet. What we are going to find is that we do need to be mindful of the state of image which we have converted into ACES CCT. So my approach, if I'm working with 709 material, I'm still going to map it into a unified log space so that I can apply my looks and get similar feel and response to what I'm getting with my other images. But I'm also going to be aware that like, hey, you know what, dude, if you want to push at 3 stops, you're out of luck. You need to be gentler with this material. You need to do less with this material. So that's kind of my rule of thumb when I'm working with stuff that is coming from that 709 color space initially, is just to take a more delicate touch. And of course, to babysit and keep a bit of a closer eye on the image. Like if we contrast this sort of Rec 709 round trip thought experiment with the actual state of things on this image, I don't worry about damaging the image whatsoever because I'm using a pipeline that's intentionally set up to preserve all of the integrity of the original image for as long as possible. But when I've got Rec 709 source material, I'm going to take a lighter touch, and I'm also going to babysit it a bit more and keep an eye out for noise or for artifacts or aberrations of any sort, in the same way that you guys have heard me talk about with the qualifier. Like, hey, you know what? When I do break out a qualifier, I know that from now until the moment I deliver this project, I'm going to be babysitting that shot and making sure that at no point is that qualifier compromising the integrity of my image. Same kind of thing here. For other reasons that we've talked about in other episodes of Grade School, I still want to map, if at all possible, into my unified log working space, but I am going to have to keep a closer eye on things and be a bit more conservative with the adjustments that I choose to make.
All right, the next one comes from Alexander Stark, and I was just wondering about how the LMTs are built for working in ACES and what their capabilities are compared to traditional LUTs.
Yeah, it's a good question. So LMTs, in effect, are sort of like LUTs plus, if you want to think of it that way. If we go back to, let's actually look under the hood of the LMT that we were playing with a moment ago. Let's look at the actual body of this cube file. If I can get it open up in a text editor here. So this LMT, in this case, it's actually just 2 LUTs. It's a shaper and it's a cube. It's nothing that I couldn't get out of a LUT, or in this case, a series of LUTs, a shaper and a cube. That's all in the world that it is. Now, there are other LMTs. Let's see if there's another. Yeah, we'll look at some of the other ones that are built in here to resolve. Let's look at the day for night LMT. I believe this one has a couple of extras built in there. Yeah, so just as an example of some of the added functions, that we can see them here on display in this LMT. We have a 3x3 matrix, which we really can't do in a LUT. We can mock it up, but there's no direct way to do a really clean per channel matrix like we might want to do for a transformation. And this one is in fact taking us from AP0 to AP1, classic application of a matrix. We also have support for an ASC CDL, or color decision list. So we can do things like modify slope offset power, which is contrast and exposure manipulation. We could also modify saturation, like you're seeing here. So there, in addition to the ability to invoke a traditional table of sample points that we're going to use to transform our image like we would with a LUT, the LMT system does have support for doing a couple of extra things that are more clean and more mathematically driven than a traditional LUT, more like floating point, like manipulating every single pixel as opposed to manipulating the image at fixed intervals of, like every, 0.05 increase of our red, green, and blue channel, for example. We can actually manipulate every single pixel in a bit more of a clean and precise way. So the LMT system is, it's got some of that functionality built in. And to the best of my knowledge, if it hasn't been sort of deprecated completely, I, to be candid with you, can't remember where LMT leaves off and where CLF comes in, which is Common LUT format, and it's another initiative of the Academy. I can't remember exactly where one leaves off and one comes in, or whether they work in parallel. But to the extent that the LMT system is still alive and kicking, I believe that it is a work in progress. So the different parameters that it tags, the different types of transformations that it supports, those may be still being kind of ratified as we speak. But the idea behind it is to say, hey, you want to apply a table of sample points like you would with a LUT? Cool. You want to do some other stuff? We're going to add that functionality in as well.
All right, this one comes from, I'm not going to pronounce that. How to apply Film LUTs while using ACES?
Yeah, $1 million question. So we started our conversation today by talking about a couple of good solutions that we might have to that. The first one would be to use our ACES 0.1.1 LMT, which is designed to give us the response of the ACES 0.1.1 RRT, which, as we now know, was designed by Fujifilm and was modeled on the mathematical models they had already built for the way their print stocks respond when you print an image onto them. So that's a very easy way to get a film-like response that's going to play nicely inside of ACES. Another option we can use that we've talked about briefly before would be to use one of these other LMTs that we have here by default inside of Resolve, which is this Kodak 2383 LMT that we have down here. Now, the only caveat with this one is it is expecting ACES linear, so it's expecting ACES AP0 linear primaries. So we actually need to do a quick conversion in order to use this properly, because if I drop it on right now, it'll take a minute to apply because there's quite a few operations happening under the hood. I don't believe that is our correct operation, although maybe I'm crazy. Maybe this is expecting ACES CCT. Let's just do a quick experiment here and do our output transform instead of to ACES CCT to ACES, and do our input transform on this side from ACES like so. Yeah, that's this is the correct behavior. So we actually want to feed our this LMT ACES as opposed to ACES CCT. So I could do that either by changing these nodes like in the way that I just did, or better yet, by building a sort of separate sandwich inside of the sandwich, if you will, which, just to quickly demo it out, would look like this. Let's delete that node. I'm going to prepend this, do another ACES transform. And I'm going to say, hey, right now you are in ACES CCT, and I want you to go to ACES, where I will apply this LUT. And then on the other end, I want you to go from ACES and back out to my working space of ACES CCT. So this way your film look is now this kind of sandwich of these three nodes here. So that would be another way of doing it there. And to very briefly summarize a very complicated topic, beyond those kind of solutions or other solutions that are set up to expect and return a color space like ACES CCT, we kind of need to rethink the way that we use film LUTs, because any traditional film LUT, any legacy film LUT that is set up to expect some kind of film log space and return some kind of normalized gamma tone curve Rec. 709 image state, we really can't use those inside of a color managed solution without heavily adapting them, which is kind of one part science and one part art. And I'm actually going to be announcing a course in the next probably 2 to 3 weeks that's going to be all about how we can build our own show LUTs. And one of the big chapters within there is going to be how we can adapt legacy film LUTs to play nice inside of a color managed workflow. But suffice it to say, unless you are working with a solution or a system that's already hip to being deployed inside of a color managed environment, traditional film LUTs are not going to do the job. And of course, there's a couple of cool tools out there. Of course, this is what my colloid tools do. And Filmbox, which just came out, is also meant to play nice inside of a color managed environment and give you a faithful film-like image reproduction.
All right, let's go to another topic, not in ACES, just to rest a little bit. So by what logic I'm doing the split toning? I don't want just to copy your curves, if you know what I mean.
Yeah, so this was a question that came in, I believe, on the last video on ditching the video look. But we were talking about the split toning subject, and I was actually surprised that, you know, like I feel like I'm talking about these things a lot, but there's always some of us who haven't yet been exposed to the idea, or for whom the idea hasn't yet sunk in. So just briefly talking about the split toning concept, which those of you who've watched that most recent video on ditching the video look, or on my secrets to cinematic grading, lots and lots of my videos cover split toning. So you can go back and look at those if I'm buzzing through this topic too fast for you today. But the essential premise of split toning is to add cool colors into the shadows and warm colors into the highlights. Why do we do this? A couple different reasons. The first one is that if we think about sort of the operation of the human eye, and we think about the way depth relates to color, I want you guys to do a thought experiment for me. And imagine that you are standing, I always think about going to Palm Springs for the weekend, and I think about standing, I like to golf, so I think about standing like on pretty much any tee box that you're going to be on at a golf course in Palm Springs. You're going to look out, and off in the distance there's going to be mountains, right? Are those mountains going to be very cool in color, or are they going to be very warm in color compared to the rest of my immediate surroundings? They're going to be cool, right? And if you think about, like looking at a sunset, the further something is away from you, the cooler it appears, right? The more difficulty those warmer wavelengths have difficulty reaching your eye, the further away that they are. So the first thing that split toning does for us is it takes a 2D image and it gives us literal, or the feeling rather, of depth. Okay, so it's going to, by pushing warmth into the middle and upper ranges of our exposure, it's going to kind of foreground things like faces and middle exposed elements. And by pushing cool colors into things below that threshold, it is going to background those things and sort of make them pleasantly recede and create this sort of like layering or depth that we wouldn't have without them. The other key factor that it's going to do is it's going to give us some color harmony by saying, oh, if I push sort of a blue cyan cocktail down here and kind of an orangey gold up here, those are complementary colors, the most fundamental color harmony we can create. And by pushing these two different tonal segments of my image in these opposite directions, I'm subtly introducing a color harmony, which is of course visually pleasing, or at least it can be. So those are some of the kind of benefits. And to answer the question of by what logic, those would be sort of like the concepts that I would be keeping in mind when I'm applying split toning. So for example, I might push pure blue or pure green or anywhere in between into my shadows, but I'm not going to push warm colors into my shadows because I don't want to make, I want to make my shadows recede rather than advance on me. And similarly, if I'm pushing, doing the shoulder of my split toning, I'm going to push maybe a pure yellow, maybe a pure red, maybe somewhere in between, but I'm not going to push a cool color because I want the things that are resting at middle and upper exposure not to recede, but to move closer to me perceptually. So that would kind of be my logic in terms of applying split toning. And we got time for...
Is there...
Sorry, go ahead.
Okay. Another one?
Yeah, let's do one more.
Okay. Cons of using DaVinci White Gamut versus using stock settings with color space transform?
Yeah, so I mean, that's a great one to close out on. So I'm going to show you guys my number one con, which you might think is a silly one to place so much emphasis on. But let's just do, because we're in ACES and we're talking about ACES today, I'm going to answer this question in an ACES context. But the question is fundamentally, what are the disadvantages of using of setting up our color management in our project settings versus setting up our color management in nodes, regardless of whether that color management is Resolve Color Management or ACES or some other undiscussed or unspecified system. I'm going to show you guys a couple of them, starting with what I find to be the most problematic for the way that I work. So right now, let's just look at this image that I have here. I've got my stock ACES transformation sandwich being set up. And if I want to see my original image, my raw on-process negative, and you guys have heard me talk before about that being a regular thing I refer back to, because one of the things that I like to do with my collaborators is I like to calibrate our vision and say, okay, let's talk through this real quick. Let's start by looking at our raw, unprocessed, straight out of camera negative. And I'll start here and just do a bypass all nodes, which I can do with Shift D, or I can hit this little kind of Sonic the Hedgehog looking thing up here to bypass all my nodes and see the negative in its original state. And then I'll build from there and say, okay, so that's what that looks like. And now here you are with your stock color management. And then I would start to add sort of modules of our look. And I'd say, well, here's what I think we should do for our stock contrast curve. And then I might say, well, here's what I think we should do in terms of setting our sort of global color temperature. I think we should cool things off a little bit. And I would audition those various modules from my collaborator, building up from a completely unprocessed raw negative. So the number one thing that is a deal breaker for me with doing project-wide color management is if I set up the exact same system here inside of my project settings, Alexa in, Rec 709 out, save, and I go to bypass all nodes, nothing happens. I can't ever see my image in its original log state, which for me is a deal breaker. And just to quickly round out some of my kind of top cons here, the other one for me is strictly a visual conceit. I want to actually see those transformations expressed in nodes, because that's not an afterthought or something that I do at the beginning that I never think about again. It's a core part of how I, as the artist, am shepherding this piece of raw camera negative from that state all the way into its final output state. The color management has just as much of a role to play as any creative manipulations that I'm going to be making. So I want to be able to enable and disable each of those things in turn, and I want to be able to visually see that journey. And you guys have heard me talk before about one of my favorite features in Baselight is something called the color space journey, where I can actually query Baselight and say, hey, Baselight, on this shot that I'm on right now, can you summarize the journey from original camera negative out to display, every single color space transformation that's taking place? And it'll do that for me in a very organized fashion. The closest I can come to that in Resolve is to set up my color management in nodes rather than at the project level, so that I've got that sort of like explicit visual access to what's happening. And it used to be that there were some additional advantages. That it actually used to be quite difficult to get upstream of or change the IDT for your color management when you're setting things up in the project settings. That stuff is no longer the case. We've got a bit more flexibility there. So I would say those are some of the key factors for me that go into saying I'd rather do it in nodes. But I would also say that in contrast to a couple years ago, maybe, there's no reason to be afraid of doing things at the project level if you find that it works better for you. Ultimately, if you can get a good looking image out of the deal, there's no compromise in terms of the way you're manipulating it. It's more about process and more about the context that you like to have as you're working for yourself, as well as the people that you're working with. So that's a great one to wrap it up on. And actually, bonus round, really, really fast, because I did want to audition this for you guys, just in terms of, like the various solutions to, like the things like the gamut clipping issue that we've identified and talked about in some prior videos, and I think even in an episode of Grade School. You guys may know, like I've got an image here that is sure to bring up an issue that I've identified before. Let me make sure I've got all my color management turned back off here. And I'm going to go back to my happy place of applying my color management in nodes. Take a quick look at this image. What do you see? By the time I apply this transformation, I've got some kind of nasty clipping happening here in my tealy cyan region here, because this is a very bright, very saturated set of pixels up here. And as we've talked about before, this is because the color gamut of my ARRI log C, my ARRI wide color gamut negative, that gamut is actually slightly larger than AP1, which are the color primaries for ACES CCT that I'm mapping into here. So we've talked about kind of some various workarounds and solutions, and this has been one that has been a prominent issue that a subcommittee of what's called a virtual working group of the ACES committee have been working on for some time. And Rafa, if you wouldn't mind, you can actually, for those of us interested, leave a link to this page right here. Actually, this is the ACES change log. We don't need to look at that, but we have a link handy in the doc for the gamut compression implementation working group. And so they've been working on that. And I also just wanted to point out to you guys, in ACES 1.3, which is a new release of ACES, which we don't yet have access to in Resolve, there actually has been a solution implemented for these gamut clipping errors that are traditionally encountered with high color volume stuff when coming from a larger color gamut than ACES AP1. And the sort of forerunner or predecessor to it has been this gamut compressed DCTL that you can see here, which when I drop it on, it's an OpenEffects DCTL. I have some parameters that I can modify, but at its outset, you can see just when I drop it on in its default form, it is solving my issue quite tidily. One of the many things that's cool about this compression algorithm is it is invertible. So we're not actually cutting off or, like irreversibly compressing our color volume. It can actually be recovered back into its full volume at a later stage. So this is this kind of underlying technology in some form that we're going to find in ACES 1.3, and that is going to make our lives much easier when it comes to this kind of gamut clipping issue that has been a problem in ACES CCT for quite some time. So I just wanted to point that out to you guys, and Rafa can leave the link to that virtual working group as well as to this DCTL. If you guys are hip to DCTLs, want to pull it down, start using it in your ACES workflows while we wait for ACES 1.3 to turn up in Resolve. This is a really good, really clean, really broad solution to that gamut clipping issue. And that was kind of the last thing that I wanted to talk about today in ACES, because it's one of the kind of key characteristics of ACES that used to be one of my core considerations, is like, hey, am I going to be dealing with images that have a lot of this kind of business of like highly bright, highly saturated sources that are going to break on the input stage, and I'm going to have to custom tailor solutions for. That used to be a reason to avoid ACES if the project was going to have that stuff. And I would say for now, especially with ACES 1.3 right around the corner, we no longer need to take ACES off the table just because that's the type of image that we're going to be dealing with. So I hope that's some helpful stuff for you guys. I hope everything we've talked about is some extra insight and sort of a window into the way ACES does work, the way it can work, and how we can tailor it to best suit our technical and creative needs. As always, really glad to hang out with you guys here for grade school on Friday morning. I want to just mention to you guys one more time the Learn with Masters event that's coming up later this month on the 26th. Definitely check it out. There's going to be like a dozen of us at that thing, and I'll be learning as much as you guys by listening to the really, really smart, really talented artists that are going to be speaking at that event. For my part, we're going to be talking about image science and specifically how we can use it as a creative compass. So rather than thinking of it as a, like an end unto itself, we're going to be talking about how we can harness image science to get better images, to be better artists, which is a topic that is very near and dear to my heart. And I've got some really cool tools and concepts to share with you guys. So I hope you'll join me for that. If you do want to join, you can go over to the website and use the promo code Cullen10. That's CULLEN, and then the numerals 10, and you'll get 10% off of your registration fee, which, by the way, is going to COVID relief support in India. So good cause that you're supporting as well. Thanks as always, guys, for turning up for grade school. Thanks to Rafa for co-hosting with me, and looking forward to seeing you guys in the next video and the next episode of grade school. Have a great day.